The paper that you just received correlates to the second test that you took this semester. We'll review this today. Tomorrow we will review stuff from test 3. Caroline, you're going to want to listen to this. Wednesday, you will take the first half of the retake. Thursday, I can tell you with about 95% certainty that we're going to just be in the lab. The second half is going to get pushed back to Monday. I'll confirm that next period, but I just don't see it working out any other way. Even in first period, got a bunch of kids testing. Half the teachers in Algebra 2 are proctoring Gateway. I just don't see it happening on Thursday. So let's plan on Wednesday here, take the first 15 questions. Thursday in the lab, I'll just let you guys, well, actually, no, I won't even see you. Take it back. Thursday, I don't even see my first period. I'll be with my first period. So that's like I won't be starting anything else new with them. They'll just be in the lab. You guys will be wherever your first period or testing. Now, that puts the second half of the test in on Monday, which you would think should be a good thing because it's more time to study, but it doesn't really work out that way. So I believe this week's homework is probably one of the longer ones. Like I plan in 6-week increments. So at the beginning of the semester, I had everything for the first 6 weeks planned out. About maybe 3 weeks ago, I put up everything for the next 6 weeks. And like in that 6-week block, I'm pretty sure this is the longest assignment. But luckily, you have Friday off. And I guess even Thursday off for that matter. I won't see you Thursday. So you have time to work on it to help you review then for the stuff on Monday. In addition to counting as test replacements, we're going to get all 30 questions from 2 days combined, give you a score on that too, and that is going to count as a quiz grade to motivate you to try your best. How does that sound, Miles? Pretty good? Okay. Any questions on anything I said? And then by next Tuesday, we move on. Oh, and I'm sorry, I guess I didn't mention, but Friday, you guys know about Friday? Since you guys all behaved good, Mr. Smith's going to give you the day off. There's no school Friday. So, you look happy. Do you like springing forward? No. I like the extra daylight. Cool. You too? There you go. Juan likes it, so I like it. Alright, so let's, I intended to do the odds here, and I'm still going to, but for these first 8, let's just do all of them because they're pretty quick. Actually, no, I think I did all of them for the first 12. So number 1, you normally don't see a log up in an exponent, but the more important thing is that the variable is also up in the exponent. The base of the exponent is a 9, but we also have a log base 9 there. So in effect, what's going to happen with the 9 and the log base 9? Yeah, they're going to cancel out. So what are we just left with? 2z. What should we do for the next one? What should we do for the next one? This doesn't have a variable. So it says simplify, but since it doesn't have a variable, what's another word that can be used? Who said it? Caroline, was that you? What'd you say? Yeah, you can evaluate that. What are the 2 main ways to evaluate logs? Change of base. So that's the one you like because it's a calculator. Or common base. So I'll figure most of you would pick change of base. And on your calculator, you will put log of 1 over 25 divided by log 5. But just to show you that they both work, I'll do common base. It's the same thing as saying log base 5 of 5 to the negative 2. 5 to the negative 2 is 1 over 25. The bases cancel. That gives you negative 2. And you can just confirm on your calculator that you got the same thing. Right, Lydia? Type, calculator. Did you get braces and that's why you're not smiling? No. Is it Zeke? Are you mad at Zeke? I'm mad at Zeke. Number 3, rewrite. In what form is number 3 right now? What form is number 3 in? It is exponential. You remember that we said that if b to the y is equal to x, then log base b of x is equal to y. So for number 3, we're doing this, and for number 4, we're doing that. So how would I rewrite number 3? This is a true statement. 6 squared is 36, but how would I rewrite that in exponential form? Log base 6, the base stays the same. So log base 6 of, yeah, just flip-flop the 2 and the 36. Log base 6 of 36 is equal to 2. Yash, you want to do number 4? Yeah, man. Rewrite it. Now, this one's in logarithmic form. Let's go back to exponential. Okay, well, it wouldn't have log because it's currently in logarithmic form. We want to get rid of the log. Now, you want Landon to help you? Come on, Landon, save the day. This looks like a job for Landon Stansberry. No. 5 to the q is equal to 30. That's it. Just rewriting. How did the time change affect you, Landon? Not that much. Look at 5 through 8. What do all those say to do? Evaluate, but these are going to be some nasty irrational numbers. So we're going to just use change of base. I wish that the directions would have said to round. Let's just round to the nearest hundredth, I guess. So for number 5 in the calculator, we would put log 112 divided by log 9. That's change of base. Tell me what you get. About 2.15. The retakes will be multiple choice, so however many decimals they go to, you go to the same thing. Last period, somebody for number 6 tells me, yeah, log 16 divided by log 10, which at least they realize that, yes, this is a common log, the base is 10, but why is change of base not needed? Why? Meaning? What's the point of doing change of base? We just finished doing change of base. What's the whole reason behind doing change of base? Yeah, I know, but why? Like, why do I use change of base to evaluate? Why do I need to use change of base to evaluate? The calculator can't do base 9 logs. Some calculators can. Most don't. What are the bases that calculators can do? 10, which is a common log, and E, which the ln is a base of E. So they can do base 10 and base E. So if you don't have a base 10 or a base E, you have to change the base. In this case, you change it to a base 10. But look at number 6. What type of base is on number 6? Yeah, my calculator can already do that. So just type in log 16. What do you get with log 16? 1.24? 204? Okay, so 1.20. To illustrate my point further to the person who told me to do log 16 divided by log 10, I said, okay, well, let's look at the second half that you just told me to do, log 10. Put that in the calculator. What do you get with log 10? And luckily, this kid did not need a calculator to tell me that, but that was pretty good. It's 1, and so really by doing that, you're just dividing by 1. Anything divided by 1 is itself. There's no need for that. For number 7, there are no specific directions given. It just says to evaluate. This is going to be an irrational number, so if you want to type it as you see it, luckily the calculator also does ln's. What's the base on an ln? Yeah, so but I don't have to do any type of change of base. I can just type it in. But just to show off, you can have more friends. What else could I do here if I wanted to make it easier to put into the calculator? You can put it like that, it's fine. Product property. If I wanted to, I could also get the 10 and the 7. And you could see a problem structured that way, where they would put ln of 10 plus ln of 7, and they'll be like, oh, which of these would give me the same output as ln of 10 plus ln of 7, and it's 70. Last period, somebody told me 17. What did that person do incorrectly? Yeah, they added, but this is product property. I don't care which one you put into the calculator, but when you do put it into the calculator, what do you get? 4.25. Thank you, Josh. Take that, Landon. For number 8, same thing. You can just type it into the calculator as you see it. But there's one, well, okay, let me rephrase that. You could type it in the calculator as you see it, but when you put it in the calculator, what are you going to have to do? Well, you'd have to do change of base because your calculator does not do base 3 logs. So if you were to type it as you see it, you'd have to do 2 change of bases because there's 2 logs. You'd have to do log 110 divided by log 3, and then close that parentheses out, and then minus log 5 divided by log 3. Or you can just say, hey, since these bases are the same, how could I combine? Quotient property. 110 divided by 5 is 22. So if you just wanted to write a single log in the calculator, that's what you would do. Log 22 divided by log 3. And what is that approximately? You guys talk too low. You're 2.89. 2.81? Why is Jenny getting 2.92? I think you should settle this on the court, Caroline. Log 22 divided by log. Yep, 2.81. It's all Jenny's fault. Yes, ma'am. Any questions on anything I've done so far? All right, number 9. I'm going to do 9, and then you're going to do 10. And I'm going to do 11, and then you're going to do 12. And then after that, we'll go to just the odds. For expanding and condensing, especially expanding, to me, I think it's easier to do it in one step. You can do it as many steps as you want. I think what's key here is to realize when you expand, right, you're going to give a log to each of these factors. How many different logs am I going to create on number 9? 1, 2, 3, 4, and 5. So I think I heard somebody say 5. And when you are fully expanded, what should we not see? Shouldn't see any exponents. Any factor that comes from the numerator, that log has to be positive. Any factor that comes from the denominator, that log needs to be negative. You can follow all those rules. My first log here would be, so log base x, everything is going to be log base x. The first one is the 8. Plus, because we also have the y squared, but that squared would come to the front by a power property, log base x of y. Now we move down to the denominator. Those logs are going to be negative, so minus log base x of 5 minus log base x of z minus log base x of w. You can do that in several steps if you want, or I just did it in one step. Now, evaluating is independent of either condensing or expanding. So once I'm done expanding, if anything there can be simplified or evaluated, you would do so. But all of these logs have a base of x. There's no x's anywhere in there inside the log, so that's all I can do. We're done. Why don't you do number 10? I'll give you like a 30-second head start. Sophie's going to beat all of you. Sophie. What does it spell? Sophie. Sophie. Yay, Sophie. Expand that log. Expand that log. Expand that log. Dun 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 dun. Expand. That's what you should have. That's what you should have on your paper. If you do not, say something now. We can figure out how it got there. Jonathan, is that a question? You're not sure how I got a number there? No, good to go. Isha, how about you? More or less? Less than more? Kendall, you seem distant today. You okay? Alright, let's go to condensing then. In order to write as a single log, what needs to be true? Same base and same coefficient, which commonly the common coefficient tends to be a 1, because you can always use power property to get rid of something. Are all these logs ready to be combined? Au contraire, mon frère. They have the same base, but who's not complying? Yeah, the second log, it's got a coefficient, so we got to move it. We're going to get this 1 over 5 and use power property. For these, you might want to do more than one step. You could. I could do this in one step. But like I like to take an extra step just to get them ready to combine. So I'm going to do log base 3 of 15. What am I going to write on the second one? You could write plus log base 3 of y to the 1/5, but I'm going to take this chance to confuse you because you know how I love to confuse you. And I'm going to write it this way. What did I just write? Whoa, why is you tripping? What is a 1/5 power the same as? It's a fifth root, yeah. So this just gives you another way of writing it. You can write it however you want on your paper. If you want to write y to the 1/5, be my guest. But you never know, this could show up like that. So a 1/5 power is the same as a fifth root. Minus log base 3 of 3, but Mr. Romero, you said that if you can evaluate, do so, right? What is log base 3 of 3? 1, yeah, but and it's not that it can't be evaluated. It's just that would ruin everything. I'm trying to write as a single log, and if I change that to a 1, that's going to mess things up. So I'm going to leave that as log base 3 of 3 for right now, and then minus log base 3 of x. Let's condense it first, and then if anything can be simplified afterwards, then we'll do it. Now that I have all the logs ready to go, I'm going to write a single log. So I'm going to write log base 3. What's going to go on the top of the fraction? The 15 and the fifth root of y. What's going to go on the bottom? And then I'm done, right? This is what got you guys back on that test. Now that I've combined everything, if anything can be simplified, you would do so. What is 15 divided by 3? 5. And since 5 is 5 over 1, the 5 stays on top. So log base 3 of 5, that's not a cube root, sorry, fifth root. Fifth root of y. Right. 5 fifth root of y over x. And that's what we're done. Sophie, you just asked for the paper and you're not even gonna write on it? You just wanna have it? Gotcha. Why don't you do 12? I'll give you again another 30-second head start while I motivate you. You finished, Arzu? Good. Kendall hasn't finished yet. That's what you should have ended up with. Log base A of 25 over 6z squared. If you're not sure how I got that, let me know. Some things that could have maybe confused you. Hey, Romero, where'd you get the 25 from? I don't get it. Or at the end, how'd you get the z squared from? Those I would think would be the two most common questions. So Landon, tell me, where did I get the 25 from? Good, yeah, this 2 came up at the beginning using power property. Since I can take 5 to the second power, I went ahead and did so. And Caleb, at the end, how did I end up with z squared? No, Alexi knows. Yeah, I ended up with 1z on top and 3 z's on the bottom because z to the third means z, z, z. Z, z, z. Sleeping. And when one of the z's cancels, how many z's stay on the bottom? 2. Hang in there, Alexis. Any questions so far? All right, so now when we get to the solving, let's just stick to the odds. What type of equation is 13? And what we were taught back with exponential was to isolate the base, but there are 2 bases. Now, luckily, they're both isolated. There's a base on each side. And not that you have to, but to make your life easier, which one that I recommend for you? Like, the reason why we isolate is to remove it. Can't remove both, huh? The smaller one, yeah, so that's what I'm going to do. So I'm going to do log base 9 on both sides. Edvin, you play soccer? What's your soccer number? 8. Do they still do it where, like, the best player on the team wears, like, 10, and then the second best player wears, like, 9? No. Are you better than Randy? Yeah, probably. He's just being modest. All right, so on this side now, power property brings the 2x to the front. What is log base 9 of 27? Yeah, 1.5, which is really 3 over 2, but we can put 1.5. And then power property also brings this to the front, so it becomes multiplication. So we get 2x is equal to 1.5 times x plus 4. I'm going to distribute, then minus 1.5x, so 0.5x is equal to 6, divide by 0.5, x is 12. Am I done? Am I done? Am I done? Yes. Ha! I tricked you. Yes, we are done. Why are we done? On exponentials, you do not need to check for extraneous. Which are the ones that need to be checked for extraneous? Yeah, logs. Who remembers what? Who could give me a good reason why? Yeah, I want to say this was kind of a question that showed up on your performance final. Why can you forego the checking for extraneous on exponentials? Remember when we graphed exponential functions? What was it? What was the domain on an exponential? Yeah, all real numbers. So either one of two. If you can find a solution, you found it. If you can't, I mean, it's still possible to get no solution on an exponential, but it's not going to be because it's extraneous. It's just going to be because you couldn't find a solution. There was no number that exists. But if you're able to find one, and you didn't make any mistakes, there's no need to check for extraneous. Isha already checked for extraneous, so she's good. No questions? All right, so let's go to 15 then. What type of equation is that on 15? Also exponential. We want to isolate the base. Here there's only one base, meaning that there's only one number that has a variable in the exponent, and that's already by itself, so how can I get rid of it? Log base 4 on both sides. Now, unlike the last one that we just did, when we had to take log base 9 of 27, log base 4 of 5 is an irrational number. Put it in your calculator so you can see it. And that's a big mistake I think a lot of you do, is that you round too soon. Earlier, remember you guys back there were getting one answer and Jenny was getting something else? I don't know for sure, but I believe that the issue could have been that she rounded too soon. So I'll leave it as x minus 1, and since I can't do log base 4 of 5, I'll just leave it as log 5 over log 4. Isha, is that how you left it? As log 5 over log 4? Plus 1 plus 1. X is equal to log 5 over log 4 plus 1. If you are asked for it to be exact, that's the only way you could leave it exact. But there is a very good chance that you'd be asked to round, or this being multiple choice, that all your multiple choice answers are just rounded. So now go ahead and put that in the calculator and tell me what you get, just in case they ask you to round. What is that approximately? What you doing, girl? Should be log 5 divided by log 4. You can put plus 1 now, I'd probably do it, but I like to hit equals and then plus 1. You're getting 2.16? Careful hydrating there, Caleb. What does it say, dream? Who wrote on it? Oh, motivation? Got you. All right, 17. What type of equation is 17? It is logarithmic. But there are two logs here. The only thing that's 100% foolproof that will always work is to get those logs on the same side so that we could use a log property to put them together. But eventually what we're trying to do is isolate the log. Both of these logs are not only isolated, they have the same base. So we learned the trick that said that if you wanted to, yeah, it's almost like they just cancel each other out and you're just left with the insides. So minus x plus 5 plus 5. X is cancel, 5 cancel, 6 is equal to 2x divided by 2. 3 is x. And then we're done, right? This is the first logarithmic equation that we do. Huh? I'm not done. On the one before I was done, because like the last two that we've done have been here on number 15 and on Number 13, these were both exponential equations. Exponential equations don't need to be checked for extraneous, but logarithmics do. So I need to check to make sure that log base 4 of 3 plus 1 is equal to log base 4 of 3 times 1 minus 5. This gives me log base 4 of 4. This gives me log base 4 of 4. I have already done enough to prove it. That's it. I can verify that both sides are the same. I do not need to go any further. But in this case, you could if you wanted to. What is log base 4 of 4? It's 1, yeah. So, like, there's no need to evaluate. I've already shown that both sides are equal. What? Did I write something wrong? Oh, I'm sorry. This should be 3 times 3. Thank you. Not 3 times 1. Okay, but it still gives me 4. 9 minus 5 is 4. That's Camila's fault. Okay, good. All right, let's jump to 19. What type of equation is 19? What? It is logarithmic. All right. So luckily there's only a single log, but in order to remove a log, we have to isolate it. There is more than one way to do it. What would be the best way to do it here? Yeah, divide by 2. The only reason you would try to maybe get away from that is if you don't like what dividing gives you on the other side. But if in that case, you could use power property to move the 2 up here. But then I'd be squaring a binomial. Me no likey. So I like Hannah's idea better. Let's just divide everything by 2. It cancels out these 2's. Is that a base 5? I can't see. Log base 5? Log base 5 of 4x minus 5 is equal to 3. Now that I have isolated the log, how do I remove a log? There you go. One person note. Remember, is good. Change to exponential, which is what we did up here, Yosh. This thing that we were doing up here, that's what we do now. What's going to be the base of the exponent? 5. What's going to be the exponent? What type of equation does this give me? Linear. This is linear. Plus 5 plus 5. 130 is equal to 4x. Divide by 4. 32.5? Good. 32.5 is equal to x. Yash, are we done? What do you think for this one? Yeah, we're done. Why not? Yeah, it's a log. You gotta check. So let's check for extraneous. I'm gonna get that 32.5 and plug it in exactly as I saw it at the beginning. So I gotta check to see if 2 times log base 5 of 4 times 32.5 minus 5 gives me 6. That 4 times 32.5 minus 5 gives me 125. And I know log base 5 of 125 is 3. 2 times 3 is 6. Did it work out? Yes, it did. Fax machine. Do you know how to draw a sphere? I bet you don't. Come on, Juan. Okay. This probably will be the hardest of the equations that we've done so far, and not because it's meant to be hard, just you got to make sure. There's 2 logs. Luckily, they're already on the same side, but unlike the one that we did on the other side of the page, where they each had their own specific side and there was nothing else, here we have a 2 that's clogging up the right side. So even if you wanted to, you could not send one of the logs to the other side. We're going to have to keep them there and combine them. What property can we use to combine them? Product, good. So this would be a single log of x squared plus 15x. When you multiply x times x plus 15, 1 gets x squared plus 15x. Isha, what are you going to do next? We literally just did it like 2 minutes ago. We're going to do the same thing again. So now that I've isolated the log, how do you remove it? Isha only. Two minutes ago, 120 seconds ago, did the exact same thing. Zeke? Very good. Change to exponential. So what's the base going to be of the exponent? 10. The base 10 log. 10 squared is equal to x squared plus 15x. What type of equation is this? Huh? Quadratic, yeah. So I treat it quadratic. I make it equal to 0. Now at this point you can do quadratic formula, which I doubt will show up on the test, so you better make sure you memorize it if you're somebody that uses quadratic formula. Or can you think of two numbers that multiply to give you negative 100 and add up to 15? 20 and negative 5. X plus 20, x minus 5. That's going to give you negative 20 and 5 as your two possible solutions. Are we done? Why not? You gotta check for extraneous, and since you understand logs already, there's not like a new concept anymore. You know that if you were to plug in this negative 20 right there for that x, even for the other one too, because even if adding 15, that gives you a negative. What happens if you take a log of a negative? Yeah, it gives you an error, so I know that's not gonna work out. If the 5 does not work out either, what happens? No solution. But let's check L50. Log of 5 plus log of 20, because I just did 5 plus 15 already, gives you 2. There's nothing else that you can really do there without the calculator. Do not use log properties to check. The whole point of this is to avoid using log properties. That could give you a false positive. So just put in the calculator log 5 plus log 20 and hit equals. What do you get? You do get 2. So this checks out. 5 is valid. All right, so for the last 4, these are word problems. What I did last period is what I'm going to do here. Let's go to all 4 of these and write the function. Okay, I want to be able to at least write the function on all 4. And then after that, depending on how much time we have, I was able to finish doing the odd ones. But we can at least it gives us a chance to talk about all of them. Mike just bought a car for $18,000. The car decreases in value by 5.75% each year. And how many years will the car be valued? Okay, well, there's 2 questions after that. But let's just write the function. All right. So the amount after some time is equal to the original amount. What's the original amount? 18,000 times the growth or decay factor. Is this growing or decaying? It's decaying, so it will be 1 minus the rate. What's the rate here? 0.0575. So you can do 1 minus, and I'm just saving space. That's going to give me 0.9425. Yes, sir. What formula? No, that's for geometric sum. We're not adding up. Huh? Yeah, but the thing is, you're not. How can I say this? You're not adding up what the car is worth every year. It's not like, so it's saying like, all right, when you bought it, it's worth 18,000. Multiply that by 0.9425. What's 18,000 times 9.24? Times 0.9425. So in the second year, it's going to be worth 16,965 times 0.9425. In the third, after 2 years, it's going to be worth $15,989.51. We're not asking you to add all those dollar amounts up. This has nothing to do with sum. Yeah, the formula I'm using here is the amount after some time is equal to the original amount, which I think we had like a lowercase a, times 1 plus the rate of change to the power of time. And since this is a decay, I changed it's a minus the rate of change. That's the one I'm using here. I don't know of any other formula that would work. And then I just put the t up here. So we probably won't get to doing this one, but we can at least talk about it. If I want to know in how many years will her car be valued at 9,000, where am I going to put that 9,000? No, where am I going to put that 9,000? Over here, that's a dollar amount. For part B, where it says if she waits 8 years for to sell her car, how much will it be worth? Where would I put that 8? Yeah, where it says T, we're in the time. 23. We can try to do all parts of 23. Lucy deposited 11,000 into an account that earns 2.5 interest compounded continuously. So this one had its own specific formula. Who remembers what the formula was for continuously compounded interest? That's the one that we call it PERT for short. The amount after some time is equal to P stands for principal. E is for the number E, the symbol E. What is E approximately? 2.71, but we have an E button that we're going to use. This was some confusion last period. The R is just the rate. You're not adding this. It's not like the one before where you have to add 1 to it or anything. It's just the rate. What's the rate here? Yeah, the 0.025, yeah. And then the time. So like for here, let's write it over here. So the amount after some time is equal to my principal, which is 11,000, times E. The rate is 0.025 to the time. For part A, where am I going to put the 20,000? Where am I putting the 20,000? Where the amount is. So 20,000 is equal to 1100 E to the 0.025 T. Well, let's solve for T now. What do we do next to solve for T? Divide by 1100. This is where we get into trouble rounding early. The 1100, I know is going to knock out those zeros, but 20 divided by 11 is going to give me a decimal. I don't want to round early because that's going to get me away from where I'm supposed to be. So I'm going to leave it as 200 divided by 11 is equal to E to the 0.025 T. How do I get rid of the E? ln, good. So take the ln on both sides. That knocks out the E. So ln of 200 over 11 is equal to 0.025 T. And then finally, how do I get, what's the last step? What's the last step? Divide by 0.025. I would put in the calculator ln of 200 divided by 11, hit equals, then divided by 0.025, and what's the time that we get approximately? I remember from last year, it's not going to make sense. I think it was like 116 years, something like that. So poor Lucy's not going to get to enjoy her money. She's going to have to probably give that to her grandkids or her grandkids' kids, something like that, her great-grandkids. It's a long time. Need a better interest rate than that. Caleb, make sense? Okay. For this part B, if she waits 22 years, how much will she have in her account? What am I going to do with that 22? So I go back to this formula up here. But now I'm looking for an amount, which makes life easier because that's already isolated. 1100 E 0.025, but now just multiply that times 22. And you can really just put that in the calculator if you know how to. If you want to do 0.025 times 22 first. And actually, I'm sorry, this should not be a T, this should be a 22. So how much money would they have after 22 years? Okay, 1906. This is money, so we should go to the hundreds. And 58 cents. Would you say that's a pretty good bank account to put money in? In 22 years, if you made, she started with 1100, now she has 9, so she made about $800 in 22 years. Is that, yeah, that's probably not a lot of money to. All right, 24. Sally deposited $1,000 into her account at 2.29 interest, compounded quarterly. Let's just write the function here, and then you can do the stuff on your own. So the amount after some time is, now look, compounded quarterly. So this is going to look like the one I wrote at the top, which is, what's the principal? What's the original amount? 1,000. Okay, this has that 1 in front. Are we gaining money or losing money? What's the rate? 0.0229. But when you compound quarterly, what's the number that goes to quarterly? 4. You have to divide it by 4. You divide the rate by 4, but then up in the exponent, you multiply it by 4t. You can try to simplify this. It shouldn't fill up the whole screen, but it's going to be a long decimal. You could try to do that to make your life easier. What's 1.1 plus 0.0229 divided by 4? Yeah, it's not too bad. It's 1.005725. That's fine. For number for 24A, where it says in how many years will her account quadruple? Well, okay, think about it. She started with $1,000. If it quadruples, what does that mean? Times 4. So what's 1,000 times 4? 4,000. Where would I put that 4,000? Yeah, you would put that 4,000 in the amount, and then you would solve. I'm not going to do this one, though. For part B, if it says if she waits 35 years, where do I put that 35? You put the 35 where the t goes. You would multiply it times 4. Shouldn't be too bad. We'll finish off on 25. 10 rabbits are released into a newly created forest. And you know how rabbits like to duplicate. So the population of the rabbits doubles every 3 years. And how many years will there be 8,000 rabbits in the forest? So this is actually, it's kind of a combination of the two formulas that we used before. So the amount after some time is equal to, how much did we start with? So the thing is, by telling you they double, that's already the growth factor. That's already accounting for what we had before, plus, like if something doubles, what rate is it going up by? No, what rate is it going up by? 100%. It's 100% of an increase. You're doubling. Well, what's 100% as a decimal? And what's 1 plus 1? 1 plus 1 is 1? There you go, Landon. Good job. So that too just becomes your growth factor. But now here's the thing: is it doubling every year? No, it takes 3 years to double. So whatever that time is, whatever the time is, it has to be divided by 3. Because it's not gonna so like after 3 years, how many times will it have doubled? What's 3 divided by 3? 1. It's doubled once. After 6 years, how many times will it have doubled? Twice. And look, this one that we will do. Where do I put that 8,000? So put 8,000 over here. Don't pack up yet. 10 times 2 to the t over 3. What would I do first? Divide by 10. That works out nicely because that just knocks out a 0 on the other side. So I get 800 is equal to 2 to the t over 3. How do I get rid of the 2? Log base 2. It's a base. Please don't divide. Now that's actually not going to work out too well. That's going to be an irrational number. So I would say log of 800 divided by log 2, I'll just leave it as is equal to t over 3 times 3 on both sides, which knocks this out, really puts the 3 up here. So what is 3 log 800 divided by log 2? What is it? Rounds off to about 29, so it'll take about 29 years for those bunnies to grow from 10 to 800. Any questions? Tomorrow we'll do the last part of the review. Wednesday is the first half of your test.